Hey folks, this is how to do proof of induction with divisibility proofs. So to show true for n equals 1, so what we're trying to show here is that 3 is always a factor of 4 to the n minus 1, no matter what value n is. So I'm going to show that it's true for n equals 1. So if 4 to the power of 1 minus 1, so we're checking, is that divisible by 3? Well, 4 to the power of 1 is just 4, and if I take away 1, just get 3. So that is divisible. So 3 is divisible to show that whatever we got there was divisible by 3. Now I'm going to assume that it's true for n equals k, so we're just putting in a k instead of the n. We're showing that 4 to the power of k minus 1 is divisible by 3. Now here we need to see that if it's divisible by 3, well then it should be equal to 3 times some number. So I'm just going to use x. You could use any number here. But if that thing there is divisible by 3, well then it should be equal to 3 times some number, where x is a natural number. Now I'm going to show that it's true for n equals k plus 1. So 4 to the power of k plus 1 minus 1 should be divisible by 3. Now we're going to work in the assumption here somewhere, but first of all I'm going to break up the 4 to the power of k plus 1 into 4 to the power of k times by 4. They're the same thing, minus 1. Then we have to remember the next step, so I'm going to break up the 4 into 3 plus 1. And the minus 1 is still there. Then if you multiply out the brackets, you're going to get 4 to the power of k times by 3 plus 4 to the power of k, and we still have the minus 1. And we don't actually have any more working out to do then. If you think about it now, that 4 to the power of k minus 1, that is, we can call that 3x, because we're just using the assumption. We've already said that that is divisible by 3, and 4 to the power of k times by 3, that obviously has to be divisible by 3, because there's 3 times it. So if you divide that by 3, you'll get 4 to the power of k. Therefore, they're both divisible by 3. And that's our assumption worked in there as well. Therefore, so we've proved it then, we've proved that that is divisible by 3. And that's all we have to do there. Here's another one then. If you want to pause the video and have a go at it yourself, feel free and play it on. Here's our 3 things that we're going to use again. The first one, I'm just going to show that's true for n equals 1. So if I put a 1 in instead of the n's in there, 7 to the power 1 minus 2 to the power 1, we have to show that that is divisible by 3. Well, that's just going to end up being 7 minus 2, which is equal to 5, which is divisible by 5. So we've shown that it's true for n equals 1. Next bit, we're going to assume that it's true for n equals k. Therefore, 7 to the power of k minus 2 to the power of k will be equal to, and we can just say 5x there, similar to what I did before, because if it's divisible by 5, then it has to be equal to 5 multiplied by some number, where x is some number. Now I'm going to show that it's true for n equals k plus 1. 7 to the power of k minus 2 to the power of, k plus 1 minus 2 to the power of k plus 1. And we're going to work from there. We're going to come up with something that is divisible by 5. So I can break it up into 7 to the power of k, 7 to the power of k times 7 to the power of 1, which is 7, minus 2 to the power of k times 2 to the power of 1, which is just 2. Then we're going to do the same trick we did last time. 7 to the power of k times 6 plus 1 minus 2 to the power of k times 1 plus 1. Then we have 7 to the power of k plus 6 times 7 to the power of k plus 7 times 7 to the power of k minus 2 to the power of k minus 2 to the power of k. Now that's not going to be good enough this time. Let's break up the 6 then into 5 plus 1. So we've 7 to the power of k times 5 plus 1 plus 7 to the power of k minus 2 times 2, 2 to the power of k minus 2 to the power of k. So we have 5 times 7 to the power plus 7 to the power of k plus 7 to the power of k minus 2 to the power of k minus 2 to the power of k. So the idea is to get a 5 because we need to have, there was a quicker way actually, a quicker step earlier, but I kind of missed it. So then if you put the 2 7 to the k's together, you have 2 times 7 to the power of k, and the 2 to the power of k is together, so you have minus 2 times 2 to the power of k. And we have the 5 times 7 to the power of k in front here. So the 5 times 7 to the power of k, that is obviously divisible by 5, which we're trying to show. So that's not the issue here. I'm just going to factorize out the 2 then in the other one. Now if you look back up the assumption, then this thing here, this 7 to the power of k minus 2 to the power of k, is part of the assumption. We've said that that is equal to 5x in the assumption, so I'm just going to let that be equal to 5x. So it'll just be 2 times 5. Well, 2 times 5x would be 10x, wouldn't it? So we end up with this. So 5 times 7 to the power of k, and then obviously both of them are divisible by 5. That's divisible by 5 because the 5 is there, the 5 divides into the 5, and this is divisible by 5 because 5 divides into the 10, and we know already that x is divisible by 5, so we've used the assumption there again. Now there was a quicker way in around there to get down further. If you had, so this line here that I did, I did that wrong, but if you, instead of that line, if you did 7 to the power of k times 5 plus 2, sorry, it might have been up a bit further actually, but if you, instead of this line, instead of that line in there, if you did 7 to the power of k times 5 plus 2, and then minus 2 to the power of k times 1 plus 1, so that would get you to it quicker. You'd have got to 5 times 7 to the power of k a little bit quicker, but as long as you can get there in the end, it's okay.